Good day, dear students. This is the second time I'm coming to you about the lesson mensuration. In our previous lesson, we looked at some few aspects about it, namely the area of a sector. In our previous lesson, we learned how to find the area of a sector. We also looked at perimeter of a sector, and lastly, we looked at the length of an arc. I hope by now my students are now conversant with these three formulas. So in our previous lesson, we looked at the area of a sector being given by the formula theta out of 360 degrees times pi r squared. Then we also looked at the length of an arc, also given by the formula theta out of 360 degrees times 2 pi r. And the last one, we looked at the perimeter of a sector. Perimeter of sector. We also derived the formula as 2r plus theta out of 360 degrees times 2 pi r. Then we learned how to memorize or how to understand the formula so that you will not find any difficulty when solving questions like this. So we learned that the pi r squared here, in the area of a sector, the pi r squared here shows the area of the full circle. So to find the area of a sector, we multiply this fraction here, that is theta out of 360 degrees, by the pi r squared. The same thing applies to the length of arc. An arc is a part of the circumference. So that one too, we multiplied the fraction here by 2 pi r. So this 2 pi r here also denotes circumference of a circle. Then we also looked at the perimeter of the sector. So for the perimeter, we saw that the perimeter comprised the total distance around the sector. So we took a part like this. Then we saw that here is radius, the length here is also a radius. And this circumference here is an arc. So the perimeter will be r plus r, which gives us the 2r, plus this portion here is an arc. So length of an arc. So these are the three formulas. But today, I want you to take note of certain things. In some situations or in some questions, they can give you the area of the circle direct. So you'll be given the area of the circle. In some questions too, which pertains to the length of the arc, they can give you the circumference of the circle. In such questions, there is no need for you to look out for a radius. So if you are given a question whereby the area of the circle has been given to you, don't find it difficult or don't think that since you were not given radius, you can't solve. So let's take a quick example to see how those questions should be framed. Alright, so let's take a quick look at this question. The area of the circle below. The area of the circle below is 180 square centimeters. Find the area of sector OPQ. So let's quickly look at the diagram. So let's take this one to be our circle. So OPQ, an angle of 120 degrees, which will be our theta. So we want to find the area of the sector OPQ. This portion here, the area. But if you look at this question, if you compare it to the previous lesson, I gave you the radius of the circle, whereby you do the substitution into the formula. But in this example here, you look at the question, they've given you the area of the full circle. So don't waste your time to find the radius first before you find the area of the sector. So you just write the formula as area of sector is equal to theta out of 360 degrees times. So instead of the pi r squared, you can write the area of circle. Or if you wish, you can still write the pi r squared. But in your substitution, note that 180 centimeters squared there represents the pi r squared because it's the area of the circle. So for this question, it even becomes easier when you know the area of the circle. So the theta is 120 degrees out of 360 degrees times, so my pi r squared here is my 180 centimeters squared. So you just write times 180 centimeters squared. You see how simple is it? So it has become so simple that you don't need the pi, you don't need any pi, you don't need any radius. You know the area already. So you just simplify this to get your answer. So we get the fraction here to be 1 out of 3. So you get 1/3 times 180 centimeters squared, which gives us 60 square centimeters, because 3 will divide 8 in 6 times. So we get the area of the sector. That's how it is. So if I should modify this question to form the length of an arc, that one too, they can give you the circumference. So if you know the circumference of the circle, there is no need for you to search for any pi or r. So assuming you want to find the length of an arc, and you are given the circumference of the circle. So let me quickly modify it. Let me make it the circumference. The circumference of the circle is 44 centimeters. Find the length. Find the length of the minor arc. Find the length of the minor arc. So in this question too, you know the circumference already. So to find the length of the arc, we all know that the length of arc, which is given by the formula theta out of 360 degrees times 2 pi r. This is the length of an arc. However, the 2 pi r here represents the circumference of a circle. And the circumference of the circle has been given as 44 centimeters. So in place of the 2 pi r, you put 44 centimeters there. It becomes very simple. So we get 120 degrees out of 360 degrees times, so don't go and write 2 times 22 out of 7 times r. You don't know any r. You can find, but it's not important. Just put the circumference there. So times 44 centimeters. Becomes too easy for you to even solve. So the same thing, the fraction there, we get 1 out of 3. So we get 44 out of 3 centimeters. Then you change it to what you want, whether you want it in some number of significant figures or some number of decimal places. Then you get your answer. Please note the units. The length of the arc length is measured in centimeters, because the circumference here was centimeters. But if it is area, you bring the square. Alright, so length of an arc. Now, I want to touch on some few aspects of the circle as we continue with this lesson. I want us to also know semicircle and quadrants. You see, the semicircle and the quadrant are special parts of the circle, whereby the theta will not be given to you, but you should know the angle that is being talked about. For instance, if you have to find the perimeter of a semicircle or perimeter of a quadrant, we know that it is the same theta out of 360 degrees times 2 pi r. This is the formula for finding our length. So length of arc. So if the arc here is a semicircular arc, the theta will not be given to you, but you must know that a semicircle is half of a circle. So that angle there will be 180 degrees. So assuming you find the length of an arc, what is a semicircle? You are going to get 180 degrees out of 360 degrees times 2 pi r. Please take notes. So for a semicircle, the angle that will be formed between the two radii is 180 degrees. And for a quadrant, we get 90 degrees because a quadrant is a quarter of a circle. So if you divide the 360 degrees by 4, you are going to get 90 degrees. So please take note. A quadrant, the theta will be 90 degrees. A semicircle, the theta is 180 degrees. That's why come in some books, they just write that half times 2 pi r. Because 180 out of 360 degrees will give us half. And the quadrant 2 becomes quarter, 1 out of 4. So that 1 out of 4 is as a result of the 90 degrees being divided by 360 degrees. So please take note, semicircle 180 degrees, quadrant 90 degrees. Then you move on with your solution. Alright. So assuming you are given a diagram like this. If this is the center, it means that the line here is a diameter. So AB is a diameter with center O. So the shaded portion here becomes a semicircle. It's a semicircle. So if you are asked to find the length of the arc AB or the length of the semicircular arc, so this is the semicircle. So the arc will be this, or the circumference of the semicircle. You can just, so assuming you are giving the radius to be, let me give you radius. The radius of this circle is 7 centimeters. So to find the circumference or the length of the arc, you get 180 degrees out of 360 degrees times your 2 pi r. Is that okay? So the 180 degrees here, they didn't give to us, but because it's a semicircle, we are going to make use of 180 degrees. Then you know your radius, so you just do your substitution. So 180 degrees out of 360 degrees times 2 times pi, of course, 22 out of 7 times our radius, which is 7, and you just solve it. So please take note of semicircle and a quadrant. But let me add this, that the circumference of the semicircle, let's solve to see what I'm talking about. 180 divides itself, you get here half. So the 2 cancels out. And here to 7 cancels out. So we get 22 centimeters. This 22 centimeters here is the length of this arc. Take note, is the length of this arc, or the circumference. But when you are asked to find the perimeter of the semicircle, please take note that the 22 centimeters here is not the perimeter. So perimeter of a semicircle is different from circumference of semicircle. If they talk about circumference of semicircle, that one is just, they want the circular part here. That's the circumference. So the answer is 22 centimeters. But when you are asked to find perimeter of semicircle, the semicircle too is a special form of a sector. Take note. Just that the two radii are meeting on a straight line. So it's also a sector. Because line OA is a radius. Line OB is also a radius. So the two radii are meeting. So we are getting an angle of 180 degrees. So if you have to find the perimeter of the semicircle, we know from our previous lesson that perimeter is the total distance around the figure. So the perimeter here, they want you to find the length, which includes the semicircle, the circumference here, and the distance there. That is the 2r. So r plus r. So if you are finding perimeter, you are going to make use of the 2r plus theta out of 360 degrees times 2 pi r. If it's perimeter, you are going to use this formula. But if it is just circumference, you will ignore your 2r and concentrate on only this one as the circumference. But this becomes your perimeter. So meaning that the 2r gives us 2 into brackets 7 plus, so this value here, we've already solved it. We had 22. So plus 22 giving us 14 plus 22, which is 36 centimeters. So the perimeter of this semicircle is 36 centimeters, whilst the circumference is 22 centimeters. I want you to be jotting certain things down as you are learning. Just jot certain things down so that it will help you. Now, in some questions, you are going to be given a sort of word problem for you to evaluate. So for the word problems, you should note that they won't do anything for you. They will just state it in words. So example like so this is a word problem about the perimeter and area that we are learning. You see that this question, they didn't draw any diagram for you. They just said the angle of a sector of a circle of radius 10.5 centimeters is 120 degrees. Calculate the perimeter of the sector. So the 120 degrees here is the angle, that is the theta given to you, and you know your radius. So it's straightforward. You just write down your formula and do substitution. So the perimeter of a sector, since you already know 2r plus theta out of 360 degrees times 2 pi r. So we know our radius, so 2 into bracket 10.5 plus the theta is 120 degrees divided by 360 degrees times 2 times 22 on 7 times 10.5. So you just evaluate this. So let's quickly go through 2 times 10.5, we get 21. 21 plus, here you can simplify it to get 1 out of 3 because 0 cancel out, 12 divides itself 1 and the 12 divides 36 3 times, for the ease of calculation, let's multiply the 2 by the 10.5 so that you can get a whole number. So 2 times 10.5, I'll get 21. So 21 times my 22 on 7. So it becomes very simple to evaluate. So we get 21 plus, now 3 can divide itself 1, divide 21 here, 7. So we get 21 plus 1 times 7, which is, okay, we can even cancel out here. So let's just cancel out. The 7 2 cancels out. So we get 21 plus 1 times 22, which is 22, giving us a final answer of 43 centimeters. That's how the word problem is. So you are taking this one as your assignment. A sector of a circle of radius 6 centimeters subtends an angle of 105 degrees at the center of the circle. Calculate I, the perimeter of the sector, II, the area of the sector. Take pi to be 22 out of 7. Take notes. The angle is given to you and the radius is also given to you. The 105 degrees here is the angle that the radius subtends at the center, so it's the theta. So try your hands on this and give me your solution for evaluation. Thank you very much.